Okay.
Previous session we discussed about what are the options. Different options are available at the configuration tab under hardware and software. Different options. What are the options we are available at the VC client? Today's session we are going to discuss about. We are going to learn about storage and networking. We left out storage and networking. How to create storage? What are the things are required under storage? And the next one is how to work on networking. Under configuration tab, these two are important configuration items which are required to go ahead and deploy the virtual machines. What are the things are required to create virtual machines? 5 components are required. Out of 5 components, 3 components are ready at the ESXi host. That is, what are those 3 components? Motherboard, CPU, memory are already ready. Now we are going to create how to provide storage to virtual hardware. We are going to create a disk to load an operating system. So how to create a disk and where to store that particular disk files, and how to assign a network for that virtual machine, how that network is communicating to outside world from the ESXi host. So coming to this storage part, how to create storage. What is a file system? File system is in the ESXi host is similar to the file system. What the file system is available on Windows Server. So we have a file system called NTFS. In Linux, we call it as a file system, ext file system. So for each operating system, there is a file system availability. So coming to that ESXi, what is a file system? How to create file system? We call it as ESXi file system, VMFS. VMFS. There are different versions are available. VMFS3, VMFS3, and VMFS4, VMFS5. Different file system. What is this file system? File system is nothing but why we are creating file system. We discussed about file system is nothing but it is going to create a layout. Whatever the hard disk is available, that hard disk, that storage, we are going to create a file system. File system is nothing but creating a layout to write the data and read the data by respective operating system. So in Windows operating system, we created NTFS file system. By creating NTFS file system, we created a partition and we assigned a drive letter and we call it as a drive. C drive, D drive, E drive in Windows, isn't it? In MTFS, what created partition and we assign a drive letter called C, D, whatever it may be. In Linux file system, they call it as mount point. They'll create LVM volume, they'll create a LVM and create a mount points. They'll create a mount point /var. So coming to that ESXi file system, how it is going to work? For each operating system, there is an independent file system to write the data, to read the data. Why we are creating a virtualization layer? Virtualization layer to support creating a virtual hardware. Virtual hardware is nothing but we discussed about it is nothing but a virtual machine, one of the software component, one of the product suite in VMware vSphere data center virtualization, ESXi host, vCenter server, VC client, web client. The last one is virtual machine. Virtual machine is nothing but a virtual hardware. We are creating a virtual hardware. To create a virtual hardware, what is things are required on virtualization layer? It is going to create a virtual machine is nothing but it is going to create a files. What is the files? If you are assigning a CPU, if you are assigning a RAM, or if you are assigning a disk, whatever things you are going to do, it is going to write the data in the form of some files. Where to write the data, where to store the data? It is going to store the data called file system. The individual file system that respect to ESXi host file system is nothing but VMFS. So while creating file system with VMFS, it is going to create what it is going to create data store. What we call it as data store. Whatever the file system, what is the purpose of file system? File system is nothing but it is going to create a layout on the storage disk. What is a storage disk? It is a hard disk or whatever the type of storage. It may be NAS, it may be SAN, whatever it may be. Whatever the storage it is assigned to the ESXi host, we are going to create by using the hard disk and respect to LAN, we are going to use in the form of by creating a file system. File system, what file system? That ESXi host is going to support file system is called VMFS. There are two versions available, VMFS3, old ESXi versions. It runs on VMFS3 file system, latest versions which are available, that is VMFS5. There are different versions are available under VMFS5 according to respective version. You can Google it and what is the version we can see while creating a data store. In Windows operating system, we are creating a file system, NTFS, and we are creating a drive, C drive, D drive, respect to drive letters. In Linux operating system, the file system, the ext3 different file systems are available. Whatever the file system they are going to create in Linux operating system, that they are going to call it as a mount point. They'll create a logical value and then create a mount points and create a respective file system. Coming to that ESXi, everything is ready. Out of 5 components, what are the 5 components are required to create a virtual machine? Out of 5 components, 3 components already ready to share. But we need to store the files. We need to write the data. Where to write the data? We need to create a file system to write the data. We discussed about virtual machine is nothing but a formation of files, formation of software code, emulation of software code. So that files where to store? It is going to store a file system. That file system is nothing but it is a VMFS. So once a VMFS is created, file system is created, whatever the component it is going to come into picture, that we are create a data store. We are going to create a name. In Windows, we created a C drive, D drive. In Linux, mount point. Here, whatever the file system you are going to create, that we are going to call it as a data store. How we are going to create a data store? We are going to create a file system with the help of VMFS and it is going to create a data store. This is an understanding how to create a file system. Now we are going to see how to create and respect to ESXi host. Before going to this ESXi host, we are going to create, we need to understand the networking concepts as well. We'll discuss both the things at one shot. File system. What is a file system for ESXi operating system? Why a file system is required? To store the virtual machines. Why we are creating ESXi host? To create a virtual machines. So what is required? It requires a storage to copy the data, to write the data, to read the data. So we need to create a file system to store those virtual machine files. So what is this file system? The file system is VMFS. And what is the versions? VMFS3, VMFS5. And whatever the disk we are going to create a file system by using VMFS, it is going to create a data store. What is a data store? It's similar. We can correlate to Windows. It is a drive letter in Windows. In Linux, we call it as a mount point. Here, we are going to call it as a data store. In Linux, ESXi operating system, whatever the storage, it is going to format. It is going to create a file system. And then we call it as a data store. We can give any name. Whatever the name you need, you can give the name. There are certain characters limitations, how much length the name should be, and all those things you can explore. What is the limitation? You can create a different names. what is a LAN, what is a local storage, local data store, finance system data store. We are going to see how to create a data store. I'm going to show you that by creating a different hard disk on a VMware workstation. We already managing one ESXi host, on top of it VMware workstation. So where we are going to practice how to create a data store. I'm going to create two hard disks in additional hard disk to create a data stores. We'll see that. Coming to the network. There is two concepts. We left out under configuration tab. We left out only storage, and networking. These two components we left out under configuration tab. So what is the importance of networking? What is the importance of network? How to understand? So we are going to create virtual machines. Virtual machines we are going to create, that is fine. What is the function? Sharing the resource, where CPU is available, memory is available. Now storage is also ready. Now if you want to communicate, establish communication from this virtual machine, I am going to create 10 virtual machines. Those 10 virtual machines on this particular ESXi host, okay, it is going to communicate. How these 10 virtual machines are, how to communicate to outside, what are the required components. I'm going to create a 10 virtual machine, that's fine. But what is the purpose? I'm going to create a virtual machines to load an operating system, server operating system. To load server operating system in the sense, it has to communicate with the outside world. From outside, whatever the user is going to try to establish communication, they should reach this particular virtual server. How to reach, how the packet is going to flow, what are the requirements. Simplest example, you have a room. In this room, we are going to have I'm going to create three servers, three systems. Three systems in the sense each system is going to have a network. What is the requirement to establish communication between these three systems? I need a device. What is the device we require? We need at least one switch, right? We need device at least one switch. So the ports are available on this particular switch. I'm going to call it as a room number one. I'm going to call it as a room number one. What is this? Room number one. In room number one, what I'm going to create? Three systems. System 1, System 2, System 3. These three systems are created. And to establish communication, what is required? I need to have a switch, right? Switch is there. That is fine. I'm able to establish communication. How to do communication? I'm going to connect with the help of patch cable. I'm going to connect these two systems like this. So that what is happening here under this particular room, what are the systems are available? System 1, System 2, System 3. These three systems are communicating. To establish communication between these three systems, I need a switch, right? Sorry, I need a switch, right? So with the help of switch, I'm able to establish communication between three systems within the room. Now, how to establish communication from this room to, I'm going to have a different system, room number 2. For example, room number 2. I am going to have 3 more systems in room number 2. Right? Same. To establish communication in this room number 2, what is required? I need a room number 2. See here. Now, there are 2 rooms are available in my building. Okay. Room number 1, there are 3 systems are available. To establish communication, what I'm going to do, I'm going to keep one switch in this room number 1. Okay. Say switch 1. Here, this particular room number 2, there is another switch available to establish communication between these 3 systems. So, how to establish communication? Okay, this room number 1, the systems are communicating with the help of this particular switch 1 to 1. How do we establish communication from this particular switch to this particular room number 2? Room number 1 and room number 2, there are 2 rooms are available. Within the respective rooms, the systems are able to communicate with each other with the help of respective switch. Now, for example, from room number 1 to establish communication to room number 2, what is required? We need an additional switch to outside. In between, there is a switch is required, right? I'm going to create one more switch to establish communication between these 2 switch 3. So to establish communication from room number 1 switch to room number 2 switch, how can I do? I can either create a functionality between these 2 switches. I'm going to create 2 ports over here, right? I can establish communication directly like this, one cable, right? So that room number 1 to room number 2 systems are able to communicate. That is fine. What is this port? We discussed about in networking concept, whatever the communication is happening between switch to switch, what is that port? We call it as, it is uplink. What is this port? Uplink port. So to establish communication from switch to switch, we need a port. That port we are going to call it as a uplink port, right? So this here only room number 1 to room number 2. Now, if I want to establish communication from different rooms, different switches, different building, what is required? There is a common switch. So there is a common switch. How to do that? I'm going to create a ports over here, right? From this particular switch, I'm going to establish communication here, right? So that from this particular room number 1, I'm able to create communication, establishing communication from switch room number 1 switch to switch 3. From switch 3, one more cable flows through, connected through switch 3 to room number 2 switch. So the communication from the room number 1 systems going to packet can travel from this particular room number 1 through this particular switch, room number 1 switch, and then packet travel to switch 3, which is outside, and travel to room number 2 switch. This is a general practice. Now, what I'm going to do is, this room number 1 and room number 2, I'm going to replace as an ESXi host. I'm going to replace as an ESXi host. How to? what it is going to happen? What is this? It is this particular, I'm going to call it as a ESX1. I'm going to call this particular system ESXi2, right? Now, simply I remove this particular things, room number 1 and room number 2, I'm going to replace as an ESXi host. What is a ESXi host? I'm going to create a systems. Whatever the systems are available in room number 1 and room number 2, I'm going to replace as a virtual machines. Virtual machines is going to have a network card, and that network card is going to communicate a switch. In room number, it is a physical word. There, the physical switch is available. Now, coming to that ESXi host, how they are going to communicate? Then the concept comes in here. Whatever the switch is available, that switch, we are going to call it as virtual switch, vSwitch. What is the terminology we are going to call it as? It is called it as vSwitch. Whatever switch is there in the room number 1, I am going to replace as a vSwitch. Here, I am going to replace this vSwitch. Simple understanding. What I did, initially we discussed about room number 1 and room number 2. In room number 1, there are 3 systems are available. How they are going to communicate with each other? There is a physical switch available. We are going to connect from system 1 to system 2. Like that, cables are going to lay down. Now, on room number 2 also we discuss the same pattern. There are certain systems are available in room number 2. There, how they are connected with each other. There is a switch available. Both room number 1 and room number 2, how they communicate with each other. We are going to create either directly connected, or we are going to create an outside one more switch in the ground floor, and we are going to establish communication from room number 1 to room number 2. This room number 1 and room number 2, I'm going to replace as a ESXi host. What is the ESXi host it is going to do? We are going to create virtual machines, that which VM1, VM2, VM3, we are going to create by using virtualization layer. Now, how they are going to communicate? To communicate those virtual machines, need a network card. We are going to assign a network card. Then how they are going to communicate to outside? So to establish communication outside, there should be a switch available. So we are going to create one virtual switch. What we are going to create? We are going to create a switch, virtual switch. What I did in the room number, simply I replaced room number 1 as a ESXi1. Whatever the physical switch is available, I replaced with a virtual switch. It is a ESXi port, there is no room. So simple correlation, like how the physical switch is converted as a virtual switch. Why we are creating a virtual switch? We need to establish communication from system virtual machine 1 to outside world. How they are going to communicate outside world? So we need to establish, create a switch. What is that switch? Virtual switch. How to create a virtual switch? We will see in networking under configuration tab. I hope it is clear. If it is not clear, just try to understand by correlating room number 1 and room number 2, how they are going to communicate. Now, this ESXi host, how this virtual switch is going to communicate outside world. In physical room switch, we call it as an uplink port. Now, whatever the ESXi host system is available, each ESXi host is going to have a network card. right? For each physical system is going to have a network card, right? This particular point, whatever the point is available here, this particular switch, virtual switch to this particular layout is going to have an logical link up to this particular port, network port from this virtualization layer, which virtual switch where it is created on the virtualization layer. On the virtualization layer, how this switch is going to establish communication to physical port of the ESXi host. Whatever the switch port, this particular switch port is going to establish a logical communication to physical port of that particular ESXi host. Once this physical port is available, this particular physical port, I am going to lay down a cable. What I am going to do? I am going to lay down a cable to this particular port. This is physical switch because it is outside. How they are going to communicate outside? The physical port is available on the ESXi host. ESXi host is nothing but a physical system. On the physical system, network port is available. How we are going to use that network port? We are going to use that particular port as an uplink port. Uplink port in the sense, what is happening? That why I'm calling as uplink port? That port is able to establish communication from virtual switch to physical switch. I told you already, communication between switch to switch, whatever the port we are going to use, that port we are going to call it as a uplink port. So what I'm simply replacing physical switch to virtual switch. What is the communication between switch to switch? And that particular switch, that uplink port, whatever the port we are going to use, that port we are going to call it as a uplink port. Why I'm calling it as a uplink port? That establishing a communication between switch to switch, I can call it as a uplink port. We discussed in networking topics, so that's the reason. Simple. From this particular ESXi host, how I am going to create a virtual switch? I'm going to create a virtual switch on the virtualization layer. I'm going to establish communication as logical. Logical, why I'm calling it as logical? There is no cable inside the virtualization. It is all logical, imagination of the cable. It is a logical link from the virtual switch to, from the virtual switch to physical switch outside. How the physical switch outside is able to communicate. So what are the port I'm going to use on the ESXi host? What are the port is available on this particular port? I'm going to establish communication to physical world by laying a cable, patch cable, connecting this. So what are the port is there here? This particular port, I'm going to call it as a uplink port, isn't it? So that uplink port, I'm going to establish communication to physical switch. Coming to the same ESXi2, same concept. Whatever the switch it is going to communicate, it is a vSwitch. Whatever the port it is going to have, there is a physical port available on the particular ESXi host on this particular physical switch. This particular port, there is a logical communication between this virtual switch virtualization layer to outside physical network port of the ESXi host. This particular logical link, this is the logical link. Just imagination, connecting a virtual switch to physical port of the ESXi host. How we are going to create, how we are going to map a physical port on ESXi host, we'll see on the networking tab of the configuration. Networking options of under the configuration tab. So once a logical link is established, I need to establish communication from this physical port to physical switch. So a cable will be connected on this physical switch. So from ESXi host 1, what are the virtual machines are there? I am able to connect individually to virtual switch. That virtual switch is connected to outside physical switch. How it is connected outside physical switch? By attaching a physical port of the ESXi host. From that physical port of the ESXi host, I am going to connect a outside physical switch. Don't get confusion. We simply replace how we replace the concept here. ESXi host 1, how it is ESXi host 1 has come into picture. It is a room number 1. In room number 1, there are 3 systems are available. And the 3 systems, how they are going to communicate with each other, there is a switch. How this room number 1 is going to communicate with room number 2. Their room number 2 also similar setup. There are 3 systems available. There is a switch available. Room number 2 also able to communicate with each other. Now, what my requirement is, I need to establish communication from room number 1 to room number 2. How can I do establish communication? There is a physical switch. One more physical switch I can use, or else directly I can connect between 2 switches. That is room number 1 switch to room number 2 switch. What is that port? We call it as, if the communication is happening between switch to switch, whatever the ports are connected, that port we are going to call it as a uplink. That is a physical environment. Now, that same physical environment I replaced as an ESXi host. Room number 1 I replaced as a ESXi1. Room number 2 I replaced as a ESXi2. So the same room, that room I'm going to use as a physical server. What is a physical server I'm going to use? I loaded an operating system ESXi virtualization layer. On the virtualization layer, I'm going to create a 3 virtual machines. 3 virtual machines are created. For 3 virtual machines, I need to establish communication. I need to provide a communication channel to send the packet to outside. So what is required? I need a switch to establish communication. What is that switch? We call it as, instead of physical switch, I'm going to call it as a virtual switch. Okay, that is room ESXi1. How ESXi1 has come into picture? Room 1 has converted as a ESXi1. For better understanding, I'm correlating each component here. Coming to the room number 2. Room number 2 is converted as a ESXi2. And that in the sense, I'm going to use one more physical server to load an ESX operating system virtualization layer created, and on top of it, virtual machines are created. Virtual machines are created, I need to establish communication. So I'm going to create one more virtual switch within that ESXi2. That is also done. Now, from this ESXi1 and ESXi2, there are virtual machines running on the respective ESXi host. How they are going to communicate outside? So whatever the port is, physical port is available on ESXi host, that is a physical system. The network port will be there. That port, what is doing that function? That port, I'm going to call it as a link, logical link from the switch 1, vSwitch, ESXi1 vSwitch. I'm going to create a logical link inside the operating system to the network port. So that what are the virtual machines are sending communication, these virtual machines are sending communication, it is going to flow through this particular virtual machine, virtual switch port to, it is how it is connected to physical port. It is a logical link, we call it as. This logical link, once it is there here, outside, once this network port is cabled with one particular physical cable to physical switch, so that the communication is going to establish from this physicals to this all 3 virtual machines. Similar way, I am going to replace room number 2 as a ESXi2. There is a virtual switch available. Under this virtual switch, there is a port, this port to mapping to the physical port of the ESXi host. So that logical link is established. Once this logical link is established, what I'm going to do, this particular port, I'm going to use one more cable, physical cable attached to switch 3. What is this switch 3? It is a physical switch outside. So what is happening here? Logically, the communication is happening from virtual switch to physical switch. Whatever the communication is going to happen, switch to switch communication, that port I'm going to call it as a uplink. So I'm using this particular physical port of the ESXi host. So this particular port I'm going to call it as a uplink. Why I am calling as uplink? Because this port is acting as a communication channel between virtual switch to physical switch. That's the reason I'm going to call this particular physical port of this particular ESXi host. I'm going to call it as a uplink port. Okay. The same uplink port is going to act as a trunk. Why the trunk? We'll discuss. What is a trunk? What is a trunk? Is nothing but it is going to allow all network related packets, VLAN, all network VLANs, how we are going to create port groups, how we are going to assign VLAN IDs, all those concepts are going to come in the under networking options. What are the things? By looking at this picture, by understanding this concept, we can create a virtual switch. Doesn't matter, we can create n number of virtual switches in the virtualization layer. But that virtual switch, I need to transfer the packet to outside world. What is required? A physical port is required. I can create n number of switches, doesn't matter. So to establish communication to outside world, I need what I need? One network port on the physical ES server. Without network port, I cannot establish logical link. I can create one more switch. If I want, I can create one more switch. If I want to create, and I'm going to deploy 3 virtual machines again in the same ESXi host, that is fine. I'm going to establish communication like this. But how these packets, how this virtual machine packets travels to outside? To travel outside, I need a one more physical port on this particular ESXi host, so that I can establish a create a logical link. I can map this virtual switch to this particular port. That in the sense, what is the requirement to create a virtual switch? I can create a virtual switch. When I can establish communication to outside world, I need a physical port, physical network port on the ESXi host, so that I can create a logical link from this particular virtual switch to this particular port. Okay, so which is to created this port is there. What is this network port? So if you want to establish communication, I can create a number of switches. If I want to establish communication from the virtualization layer switch to outside world, what is required? I need a physical port on the respective server, on the respective host. So if I want to create a number of switches in the sense, I should have those many number of ports. Here, the redundancy concept comes in picture. Generally, whatever the ESXi host we are going to use in enterprise environment, they are going to come along with 4 port or 8 port like that. Why those many ports? Because to maintain a redundancy. For example, something wrong with this particular physical port. Because it is a logical link inside entire the logical link doesn't matter, doesn't. For example, this particular port is having an issue. What is this? This physical port. This particular physical port having an issue, this physical port having an issue. So what will happen? What are the communication is there happening from these virtual machines? All these virtual machines, what happens? It is going to lose the communication. There is no redundancy. We call it as a, this is a single point of failure. So how to establish redundancy? That's the reason whenever we are going to load an ESXi host, whatever the hardware we are going to choose, we need to choose high performance server. High performance server in the sense high CPU capacity, high memory. We assign high memory. We are using blade servers. Why you are using blade servers? What is the necessity in the blade server concepts? Okay, we are going to provide high resources. At the same time, we are going to provide a more storage because we are going to create 50 virtual servers. Each server requires maybe 50 GB, 100 GB, or 200 GB like that. Storage is ready. Now, storage is also centralized storage. Doesn't matter. Okay, we created centralized storage. We are using SAN. Now, coming to the network topic, what is a we need to make sure there should be a redundancy. First, what we need to see, what is the speed of the network card, because it is supporting multiple servers. Say, for example, 50 servers are running on the inside ESXi host one. There are 50 servers. How how 50 servers are going to send communication? How much bandwidth it requires? So what are the network cards available on the ESXi host? That network card should be high throughput, high bandwidth, high performance. That in a sense, general server, if maybe 1 Gbps, but in this particular ESXi host, what are the hardware we are going to choose on that particular hardware? We need to make sure that network port is capable enough with supporting full duplex and high speed. That is, we are some hardwares are supporting 10 Gbps, some hardware supports 1 Gbps network card. One network card, one network port is not sufficient, because if something goes wrong with the respective network port, what will happen? It is going to be a single point of failure. That's the reason they are going to maintain redundancy. How to maintain redundancy? They are going to create port, one more port. Same logical link is going to establish here, say from the same virtual switch. And this particular switch, they are going to connect outside the physical switch. One logical link is from this particular switch, connected one logical link here. If I connect the switch is down, something wrong with this particular physical switch. Even that is also considered single point of failure. So there are two ports are available. Okay, these two ports, one port is connected to outside one physical switch, one more port is connected to one more port of the physical switch. So what will happen on the port level, physical port level, I'm maintaining two ports. Even one port is down, I can able to send packets. All these virtual machine packet can travel either this port or this port. Once it packet reaches outside of the physical switch, outside of the ESXi host, these two ports, one port is connected to one switch, another port is connected to another switch. So that I'm going to maintain a redundancy at the network port level, two ports. Any one port is down, doesn't matter. Even one switch is down, doesn't matter. I can send communication, I can able to communicate so outside world through another port. So that this concept I'm going to maintain as a redundancy. Even one port is down, how can send the packet from other port. So generally in enterprise environment, whatever the ESXi host physical server we are going to use for ESXi environment, definitely there may be minimum two ports will be there. Max to max 8 ports. Some hardware supports more than 8 ports also. But generally, to provide environment, 2 ports are sufficient for each communication. What we are going to create, production network, 2 ports, backup network, 2 ports, different requirements. What is the requirement to send management purpose 2 ports? Like this, 6 ports are more than enough to send the communication. There is one more requirement we are going to talk about. For each communication, they are going to establish communication and they are going to create a architecture design in such a way that in each accept they are going to make sure maintaining redundancy. So generally on high environment, very large environment within a production environment, I, I noticed 8 ports, max 8 ports, 2 ports for production, 2 ports for backup, 2 ports for management, 2 ports for other management function. I'm going to discuss what is that other management function. vMotion. What is a vMotion? We'll discuss. Generally, on any environment, enterprise environment, there are minimum max to max requirement 8 ports. They are going to separate the network flow, packet flow, because number of virtual machines are going to run on the same ESXi host. I need to make sure there is no bottleneck in the network traffic. So I'm going to create production network, 2 ports, backup network, 2 ports, and management purpose 2 ports. And there is another function migrating vMotion servers from one ESXi host to another ESXi host. It is going to happen. through management, or we can go to create a vMotion network. There are different networks available. This is the basic concept, how the virtual switch is going to communicate outside. Here, what are the ports we are going to use on this ESXi host? That ports we are going to call it as a uplink ports, because those ports are establishing communication from switch to switch. That's how many uplinks are there, how many NIC cards are there. First, you should understand how many NIC cards are there. Each NIC card, to create a established communication from inside virtualization layer to outside, what is required? At least one NIC card is available. What is that NIC card it is going to use? It is going to establish a logical link to inside the virtualization layer and a physical connection to outside physical switch. That port, I'm going to call it as a uplink. Why? Because it is establishing communication between virtual switch to outside switch. That's a concept. What is the concept here? You need to understand how the communication is happening. This is very important point. If you are not able to understand, let me know so that I can explain. It is a recorded session. You can review again and again and understand the concept. If you are not able to understand, please ping me. I can ready to explain again. Here you need to understand how the virtual machines are sending communication to outside world. That is important here. If you are not able to correlate what is a physical switch, how the virtual switch, you cannot send the packets. You can't understand how the virtual machine, how we should treat a physical system and how it is communicating packet to our physical switch. The same way here, physical switch is replaced as a virtual switch inside the ESXi host, because I'm creating a number of servers, number of virtual machines. Those number of virtual machines are need to connect to a switch. That switch I'm calling as a virtual switch. Simple. That virtual switch, what is required? It requires a physical port to establish a logical link. Once a logical link is established, whatever the port on the physical port is connected to outside physical switch. So it is sending communication, it is establishing communication from VM to virtual switch. From virtual switch to is a logical link to the physical port. From physical port, it is going to connect it to outside the physical switch. This is the way of direction. So same way, if number of ESXi hosts are available, it is going to communicate similar fashion. It is going to send communication, how the communication. You should concentrate only one ESXi host. You should understand how the virtual machine are going to send the network traffic to outside world. You should replace with a room architecture. Room number 1, there are 10 systems available. How the packet is traveling from room number 1 to main building switch. The same room number 1 concept you need to replace as a ESXi host. In ESXi host, there are virtual machines. It is all imagination. I am creating a virtual machines. That virtual machines is working as a servers, right? So that virtual machines, how the packet is traveling. This is the way we need to understand. These two concepts, like storage and storage. What is the storage? To create files. We discussed